Hello. So today we're going to look at confidence intervals for proportions. So just a different type of data, but the same general idea of a confidence interval that we did last time. So today we're going to create and interpret confidence intervals for a population proportion. So as I said, confidence intervals for proportions, which is with categorical data, we're finding the percent or proportion of something, are very similar to confidence intervals for means in terms of how we find them and also in how we explain them or interpret them. So we're going to go straight into an example so that I can show you how this works and how we use our website that we used before. So this example says the Ming Dynasty ruled China from 1368 to 1644. And in one archaeological excavation site, 29 Ming vases were found among 100 pieces of ancient pottery. So we are estimating, we're talking about the proportion of the pottery pieces that are from the Ming Dynasty. So our first question here, it says, what proportion of the sample of pottery pieces were from the Ming Dynasty? So to get that proportion, we're simply just going to divide the number of Ming divided by the total pottery pieces in the sample. So there were 29 from the Ming Dynasty divided by 100. Total would give me a 29 out of 100, which is 0.29. Or if we turn that into a percentage by just multiplying by 100, about 29%. So about 29% of the sample of pottery pieces were from the Ming Dynasty. So does this proportion or percent tell us exactly what proportion of all pottery pieces in the entire excavation site that are from the Ming Dynasty? So basically, is 29% what is true for sure for the whole population? So they're absolutely, positively, exactly 29% for the entire, all the pieces. And the answer is not necessarily, right? We know that samples are not always perfect. Even if we were to take a random sample, which is a good sample, there's still going to be some amount of variation. So think about if I were to take another sample, is that other sample going to absolutely have exactly 29%? Not necessarily. This is why we use confidence intervals to estimate what's true for a population. Confidence intervals give us a little bit of wiggle room because we know that our estimates are based on samples, and samples are not always perfect. So now we're going to actually calculate the interval. So we are using the same website that we used for confidence intervals with means, but there is a slight thing we have to change before we get started. So if I go to that website, which looks like this is where that link would take you. Before we were doing an estimate of a mean, we were finding the average something, but now we're talking about a proportion. So I'm going to click that top little drop-down bar, and I'm going to go down to where it says Z estimate of a proportion. So now I'm asked a little bit of a different information. So it still has confidence level, but now it's asking for sample successes and then N. So what that means when we say successes, it basically just means the number of items in your sample that were whatever thing you're talking about. So in this case, we're talking about what percent of Ming Dynasty is out of the entire group of pottery. So these successes would be 29. So in this example, success means just how many were from the Ming Dynasty. So 29 would be the number of successes. And then N is the total sample size. It's how many pieces there are total in the entire sample that we took, which they said was 100. So my N here would be 100. And then we wanted to find a 95% confidence interval, so I want my confidence level to say 0.95. And then once I've typed all that stuff in, it will tell me down here the lower and upper limit of our interval, just like it was with last example or last lesson. And then it also gives me the interval in terms of the sample proportion plus minus. This would be the margin of error. But usually you're going to be asked to find just the interval itself, so the lower to the upper limit. So my interval is 0.2011. Our upper limit was 0.3789. Those are proportions, which means they are in decimal form. If I wanted to, I could write that in terms of a percentage by just multiplying them by 100. So like 20.11% to 37.89%. And then what that interval tells us, remember an interval is telling us an estimate for what the true proportion might actually be. So when we interpret or explain the interval, we say something like, we can be 95% confident that between 20.11% and 37.89% of all the pottery pieces are from the Ming Dynasty. So somewhere between those two proportions is the true proportion of all the pottery pieces. And remember, the 95% confident just refers to how sure we are about that interval. And the confidence level comes from a couple of things. It comes from how confident, the width of the interval comes from a couple of things. It comes from how confident we are, or how sure we are in our interval. That's going to make it wider or narrower. And then the other thing it depends a lot on is the sample size. And both of those things we talked about last class with our means problems, with estimating a mean. But we're going to explore that a little bit with proportions as well. So the next example says, what happens to the interval if we change our confidence level to 99%? Now, you may remember from the last lesson, we found that when we upped our confidence level, the interval got wider. And that was something that we talked about a little bit. So what we learned in the last lesson is that it should get wider because a higher level of confidence always leads to a wider interval. But let's go ahead and look in our website. I'm going to change my confidence level to be 0.99. And now I have a new lower and upper limit. It goes now from 0.17 to 0.40. So 0.1731 to 0.4069. So about 17% to about 41%. And if you remember, our old interval was 20 to about 38. So my new lower limit is lower and my new upper limit is higher. So the interval did get wider, right? The lower end got lower and the upper end got higher. So we got a wider interval with a higher level of confidence. So that same thing is true as what was true last time. When we up our confidence level, it makes the interval wider. And when we lower our confidence level, it makes the interval narrower. And the reason for that, I went through an example in class, but basically confidence is not about like how exact we are. Confidence is about how sure we are that this interval is going to include the true number. And if we want to be more sure, we have to make our interval wider so that we can be more sure that our interval includes the real number. The second one says, what if we took a new sample of 1,000 pieces of pottery in which 290 were from the Ming Dynasty? So we have a bigger sample size, but 290 out of 1,000 is the same as 29 out of 100. So the same proportion of the sample, but how does that bigger sample size affect our confidence interval? Right? And just to make things a little bit easier, I'm going to keep the 99% so that we can directly compare to this interval we just got that was a 99% interval. So I'm going to go back to my website. I'm going to keep the 99%, but I'm changing this to, we have 1,000 in our sample and 290 of them were successes, were from the Ming Dynasty. So I have my lower and upper limit. If you look at the actual interval part, we can see that 0.29 stayed the same as what it was before, right? Before 29 out of 100, it was 0.29, and that was our margin of error. But now we're saying 290 out of 1,000. So I still have 0.29 as my sample estimate, and now my margin of error has changed. And that gives me a new interval of 0.253 to 0.327. So a bigger sample size, if it's still true what was true last time, a bigger sample size made the interval narrower. And in this example, our new interval is 0.253 to 0.327. So if we compare that directly with that last interval that we got, right, my lower end of my interval got higher. The upper end of my interval got lower. So we went from here, the lower end got higher, the higher end got lower, right? So our interval did get narrower, right? So we're kind of moved in a little bit. So upping our sample size did give us a more exact interval that was more precise. So we didn't have to change our confidence level to get a more precise interval. We just took a bigger sample size. Okay. The last thing I wanted to talk through was how do we know when to use the z-estimate of a mean option on our website versus the z-estimate of a proportion. It'll always be those two in this chapter. We're either going to do z-estimate of a mean or z-estimate of a proportion. So how do we know which one to use? Well, we have to look at the type of data we have, or we need to look at what words are used in the question. So this will come in handy when you guys get to the test for this unit. We want to make sure that we are using the right option on our little website. So we need to look at the data that we have or look at the words used in the question. So a means problem, you know you're going to do the estimate of a mean, which is what we did in the last lesson. If the problem is talking about the word mean, that's a good clue, or maybe even the word average, because mean and average mean the same thing. Or if they don't have the word mean or the word average, maybe look at, is this data numerical? Right? Is the data talking about a number of something? Proportions, we're going to use the estimate of a proportion on this little website. So we're going to either look for the words proportion, very good clue, or maybe the word percent, because that's kind of the same idea. Or if it doesn't have either one of those words, look for, is this data categorical? Meaning when we collect the data, is the data words as opposed to numbers? So just a few examples of each. Some examples of problems that would be means. So we would use the estimate of a mean. Would be if I said, what's the true average number of siblings per student at McNeil? Okay, so average. So we know we're using means because it said the word average. I surveyed a sample of Austin adults to estimate the mean amount of money all Austin adults spent on fast food per month. So I see the word mean in there. I'm talking about an average. This last example, the survey question is, how tall are you in inches? Well, that one doesn't have the word mean or the word average, but how tall are you in inches? That data is numerical. That's a number. So I know because it's numerical data that it's going to be a problem dealing with means or averages. Okay, for proportions data, one example, what proportion of McNeil students have a birthday in February? Okay, so proportion makes it super obvious I'm dealing with proportion, so I would choose the estimate of a proportion. Another example, I surveyed a sample of Austin adults to estimate the percent of all Austin adults who regularly ride a city bus. So percent, we're talking about the percentage of something. So we know percentage is very similar to proportions, so I'm going to still use that, the estimate of a proportion. The last example, the survey question is your favorite color red? So there's no percent or proportion in that sentence, but is your favorite color red? That is a yes or no question. That is categorical data. It is not a number. It's not numerical. It's categorical. So I would be using proportions because it's categorical data. So those are some hints to help you with knowing which one of these to use. And like I said, those are the only two options we're going to use in this chapter. We're going to either use z estimate of a mean or z estimate of a proportion. We won't use any of these other ones right now. All right, so that is it for this lesson, and I will see y'all in class.